Hello and welcome to this video on the Raspberry Pi. This is the Raspberry Pi 2 Model B. This is the 7th video in the series and looks at detection. First of all, let's take a look at the GPIO pins that we used for the traffic light project. We used a connection to a ground pin, shown here coloured black, and to any 6 GPIO pins, shown here coloured yellow. In this project, we shall use a connection to the pin at a voltage of 3.3 volts, shown here coloured orange, and to any other GPIO pin that we are not already using. Here we shall use GPIO pin number 7. This shows the circuit from the 3.3 volts pin to the GPIO pin number 7. With the switch closed, we have a direct link between the 3.3 volts pin and the GPIO pin number 7. We are using the 360 ohm resistor to limit the current between the two. With the switch open, we now have no link between the 3.3 volts pin and GPIO pin number 7. This shows the Python code that we used in the traffic light project. Here we see the pins that we used for the red, amber and green LEDs. We can also see the input pin that we are using in this project. Here we see the Python code which is necessary in order to set up GPIO pin number 7 for input. Here we print out the state of GPIO pin number 7. This will have two values depending upon whether the switch is closed or open. With the switch in the circuit open, the state of the pin GPIO 7 will be false. This has an equivalent value of 0. When the switch is closed, the logical value will change to true and the equivalent value will be 1. So at this point, when we print out the value of GPIO input number 7, we will receive the value of either 1 or 0, depending upon whether the switch is closed or open. We now use that value in this while loop. We test the value of GPIO input number 7 and test it against the value of either 0 or 1. Here we are saying that if the switch is not closed, continue within the loop, and once the switch has been closed, continue with the remainder of the code. We will now look at the items used in this project. There are 2 battery holders, a miniature low power laser, a pencil beam light source, a light operated switch, When the light switch is off or there is insufficient light to trigger the relay, these two connectors are linked. When the light switch is on and there is sufficient light to trigger the relay, these two connectors are linked. These two connectors are the power supply for the light operated switch. The one shown here is the positive terminal. This is the ground or negative terminal. This shows the photodiode. This shows the location of the receptive part of the photodiode. This LED shows when the light operated switch is powered up. The green LED comes on when there is sufficient light to trigger the relay. This shows the potentiometer, which controls the light level which triggers the relay. Here we can see those items in use. Here we have the light operated switch and the miniature low power laser. Each is operated by a separate power pack. We will break the beam by using this small box of batteries. The light from the laser can be seen as the leading edge of the box breaks the beam. We will use the Python code to calculate the speed at which the box is moved across the tabletop. Here we measure the length of the box. It's just over 2 3/4 inches. It is important to note which of the two terminals we are using from the relay on the light operated switch. This is the view from above. As can be seen, the light operated switch is now activated. Shown here is the Python code that we shall be using. As the box moves in front of the laser, we will need to calculate the amount of time that elapses between the breaking of the beam. To do that, we need to import the date-time function. Here we have two while loops. The first is triggered when the leading edge of the box breaks the beam. The second is triggered when the beam is reinstated. Here we do the calculation which is necessary to calculate the speed in miles per hour.